The experiments we do here tend to be on the fundamental side. That is, we're trying to learn about the properties of plasma. We use an electrical machine that produces a very high current. In the case of our machines at Cornell, 1 million ampere pulse power machines.
The center is fairly unique because of the experimental equipment we have, the ability to make these high energy density plasmas. The students that are involved in our work here include undergraduate students, graduate students, and postdoctoral students. All three of these groups of people are involved in the experiments right from the ground up.
We are not a user facility. We have a great diagnostics and our million ampere machine, and those facilities are used directly by the graduate students as the principal investigators of experiments.
I'm working on the gas puff system, which is a system for injecting a column of gas into the electrode gap of a pulse power machine. So this is the gas puff valve, which consists essentially of a piston that's seated against the back of a nozzle. When it's fired, gas is injected into Cobra's chamber from 3 different nozzle sections, a central jet, an inner ring, and an outer ring. And we can fill these nozzle sections with different gases at different pressures to do things like mass profiling in experiments or studying interactions between species. Gas puffs are typically used as X-ray sources or neutron sources. They generate a lot of energy, so they're useful for simulating these high energy density environments.
As soon as I started freshman year, they got me the machine training that I needed to work in the machine shop. It's definitely given me a bit of a leg up on my classmates.
We make sure that our experiments are supported by computer simulation.
With respect to computer simulation, we're interested in exploring physics. We've been very fortunate to have a computer simulation model that has capabilities that are pretty much unmatched by other codes, and that we can explore extremely dense plasma regimes, and we can explore physics that's involved with the motion of the electrons as well as the ions. A lot of the experiments that we do are focused on trying to match the physics that we can simulate in the code and try to understand basically the dynamics due to these effects that go beyond what most laboratories are able to compute.
Plasma jet experiments are performed in order to try to understand some astrophysical phenomena.
One focus of the research at the center is laboratory astrophysics, and the idea is that you can study the same physics in the laboratory as that which occurs on astronomical scales. I'm researching plasma jets, which can be relevant to astrophysical jets, given certain dimensionless scaling relations. We create the plasma jets by sending the electrical current through a foil, and that current vaporizes the foil, producing a plasma, and the electric and magnetic forces collimate the plasma jet above the foil. We then apply external magnetic fields and can change the direction of the current to look at the effects and compare experimental results with numerical simulations.
Back here we have 2 different spectrometer systems which allow us to look at plasmas at different wavelengths, and this is an example spectrum of a shot we were looking at sodium lines and using Zeeman splitting to try to measure the magnetic field.
My thesis work was really concerned with looking at the physics that occurs around aluminum's K-edge. So there's a couple features that we found in the experimental data that weren't necessarily predicted by theoretical models. So this gave us an opportunity to expose some features of aluminum's behavior that really weren't known.
By the time that I was finished with my graduate degree, there were people that were coming to me and saying, look, we've seen your work, maybe you'd like to come out and talk to us about a job later. So being part of the center has certainly opened up opportunities for me. The collaboration with Imperial College has been very fruitful. So we often find that we're meeting with these guys. So it's very fruitful to see similar experiments being performed over there and here, and you can kind of, you're comparing results and you're trying to understand where the differences are and where the similarities are.
There are very few centers in this country in which the students can participate in the experiments at all levels.
I chose Cornell to have an opportunity to work really hands-on with a pulse power machine like Cobra.
Okay, here we go. Disconnecting. 3, 2, 1. Fire.
I think they are preparing me in a broad sense for many different things, and I'm talking about more than just in my field. I'm talking about taking on a project and seeing it through to completion.
By the time a student graduates from Cornell with a PhD, they have learned how to design and implement an experiment, repair the pulse power machine, and even build their own diagnostics.